Team 3, installation and location of workpieces during processing. And Sumia with us again. And with us today, Hatime Aulamin. Can you hear me and can you see me, Hatime? I hope you can see me and I hope you hear me. Okay, let's continue. First questions, first item of our lecture is concept about basis and basing. Concepts about basis and basing. Please write down to your notes this plan of our lecture. First item, concepts about basis and basing. And 3.2, item 3.2, principles of constancy and combination of bases. Principles of constancy and combination of bases. Let's start first item, 3.1, concepts about basis and basing. Basis. When processing workpieces on machine tools, the following surfaces are distinguished. Threaded surfaces, those that are exposed to the action of the working tool. Surfaces which the help of which the position of the workpiece is determined during processing. Surfaces with the help of which the position of the workpiece is determined during processing. Surfaces in contact with clamping devices. Clamping devices. Surfaces in contact. And Ayman. Today, Ayman with us. Like a student. Okay. Surfaces in contact with clamping devices. Surfaces from which the wish stand dimension in measured. Surfaces from which the wish stand dimension is measured. And free surfaces. To ensure a central position of the workpiece on the machine table or fixture, it is necessary to solve the problem of basing the workpiece with a given accuracy. A similar problem has to be solved when assembling machines, when it is necessary to connect parts and assembly elements with the required accuracy. Given the workpiece of product, the required position according to the selected coordinate system is called basing. So what is the basing? Please write down these sentences in your note. Basing, it's a given the workpiece or product the required position according to the selected coordinate system. Giving the workpieces or product the required position according to the selected coordinate system. It's basing. Basing. A surface or a combination of surfaces performing the same function, that is a point belonging to a workpiece or product and used for basing, is called a base. Base, that is the surface that used for basing a surface of combination of surfaces performing the same function, that is a point belonging to a workpiece or product and used for basing, is called a base. Base. The design of processing and assembly technological process, as well as the calculation of errors, is connected with the choice of bases. We present a general classification of bases. General classification of bases. There are design or engineering basis. First type of basis is design or engineering basis. Technological basis. Second type of basis. Technological basis. And measurement basis. Measuring basis. Once again, type of basis is design and engineering basis, technological basis, and measuring basis. Three types of bases. Please write down this scheme in your notes. Three types of bases. Engineering basis, technological basis, and measuring basis. And next slide. Design bases are those chosen when designing a product design bases are those chosen. Design bases are those chosen when designing a product. The technological process of manufacturing or repairing a product. When designing a product, they determine the calculated position of the part according to other elements of the product. And when designing the technological process, the calculated position of the workpiece to be processed relative to other elements of the technological system. Regarding the cutting tool, fixture, and machine. Design bases in the drawings are presented in the form of geometric elements, axes of holes and shafts, symmetry planes, angle bisectors. So what can be like design bases? It can be axis of holes and shafts, symmetry planes, angle bisectors. Design bases are used to determine the position of a part or assembly unit in a product. Once again, design bases are used to determine the position of a part or assembly unit in a product. When assembling the product, the design bases of its parts are connected. Thus, the design bases are the real surfaces or the elements of the product. Second type of basis is the technological basis. So, technological bases are used to determine the position of a workpiece of product in the manufacturing or repair process. Write down these sentences in your notes. Technological bases are used to determine the position of a workpiece or product in the manufacturing or repair process. When installing the workpiece or assembly unit in the fixture, the technological bases are the surfaces of the workpiece or assembly unit that are in direct contact with the mounting fixtures. If the workpiece of assembly element is installed with alignment both the calculated surfaces of the workpiece or assembly element and the geometric lines and points represented on the workpiece or assembly unit in the form of making marks are used. there are basic and auxiliary technological bases. The main technological bases are surfaces that are an integral element of the design of the part and play a certain role in its operation in the product. For example, figure 3.1. The surface of the hole 1, and the end of the workpiece 2, this surface 2, used for basing when cutting teeth, are the main technological bases. These surfaces are the main technological bases, these holes and this surface 2 for gear. Auxiliary bases are surfaces specialty created for parts based on technological consideration, and they are not required for the part to work in product. As an auxiliary technological basis, the center sockets of the shaft, 2 installation holes, on the blanks of body parts, the centered belt 1, figure 3.1c, 3.1c. And the end 2 of the engine piston skid, special ties for the convenience of installation and fastening of castings, the used, etc. The possibility of creating auxiliary bases must be provided in the design of the parts. So we can use the main technological basis and auxiliary basis. And the third type of basis is measuring basis. Measuring basis. Measuring bases are used to measure dimension when processing a workpiece, when assembling a product, or to check the relative position of the surfaces of a part or elements of a product. Please write down these sentences. Measuring bases are used to measure dimensions when processing a workpiece or to check the relative position of the surfaces of a part. For example, according to figure 3.2, when determining the parallelism of plane B relative to plane A, this is plane A, The measuring base will be plane A. This is a measuring base. If not real surfaces of the part, but geometric lines or points are used as the measuring base, then indirect control methods are used. These bases are materialized with the help of our auxiliary parts, mandrels, a stretched string for mounting several bearings, etc. Okay, students, tell me please, is it clear what's the difference between these three bases? Between the, where's the scheme? Between the design or engineering base, between the technological base, and between the measuring base. Is it clear the difference between these three bases? Tell me, please. I hope is it clear. Okay, so now let's see some video about basing. Is everybody see this video? Can you see this video? And can you hear the?
Yes, sir, we can.
Okay.
Work holding is a term used when manufacturing products, but not everyone is aware of what this entails. Work holding, at its purest form, is simply securing a workpiece to allow for machining or other similar industrial processes to be done in a uniform and repeatable fashion. The introduction of basic work holding methods like locating and clamping paved the way for high-volume assembly and manufacturing lines, as parts were able to be reproduced accurately in mass quantities. In order to ensure that a workpiece is held securely and won't shift during machining or processing, a work-holding assembly needs to prevent movement in 12 different directions or degrees of freedom. These include 3 axes of both translational and rotational motion. Translational degrees of freedom allow movement up, down, left, right, front, and back, while rotational degrees of freedom are classified as pitch, roll, and yaw, with clockwise and counterclockwise directions available for each type of rotation. When designing a work-holding unit, consider each degree of freedom and how to limit the motion in that direction until all 12 degrees of freedom have been restricted. The amount of restriction to each degree of freedom will dictate how repeatable or how flexible a particular work-holding unit can be. Typically, a work-holding unit is referred to as a jig or a fixture, depending on whether the assembly is being used to guide a tool or operation, like drilling, tapping, or assembly of dowel pins, or is simply holding the workpiece in place relative to the cutting tool or operation. Jigs and fixtures fall into one of 4 categories, depending on the number of workpieces it will be used for, as well as the permanence of the fixture. A very unique one-off part might use a temporary general-purpose fixture, often using clamps, vices, or tools which are available in the workspace at the time, but not designed specifically for the piece. whereas low-quantity custom parts may use a disposable fixture designed for the workpiece but not meant to be long-lasting. As the quantity of parts to be processed increases, the fixture design becomes more robust, moving into modular design, flexible enough for several standard parts, and finally into permanent custom fixtures for very high-quantity part runs. While the type of jig or fixture design may evolve, the basic components used remain fairly constant. These include a support base, which usually restricts downward motion, pitch, and roll, locating pins, which restrict left, right, front, and back translation, and yaw rotation, and toggle clamps, which limit the final degree of freedom, upwards motion. Whether designing fixtures for machining or welding, drill jigs, or any other type of work-holding assembly, remember that the more effectively all 12 degrees of freedom can be restricted, the more reproducible your part can be. Factory automation components like locating pins, toggle clamps, and support bases help provide a great base with flexible options to your design. Tune in to the next episode for more on how best to use different locating pin head types.
This was first video about fixing, and now location pins.
Locating
Video
pins are
number
used in
2.
work-holding fixtures and jigs to secure workpieces during the production of parts. If you're new to work-holding concepts, check out our first episode for an introduction to the basics. This episode will take a look at the main types of locating pins, head shapes, and the primary uses for each one. There are two classifications of locating pins, two-way and four-way. A simple method to remember the difference between them is to consider the 3 axes of translational motion and the 6 corresponding directions or degrees of freedom. A two-way pin restricts motion along one axis, or 2 degrees of freedom, like a round pin in a slot. Likewise, a four-way pin restricts 4 degrees of freedom along 2 axes. A round locating pin located concentrically in a hole is a common application of a four-way pin and helps to further secure. A minimum of 1 of each type of pin is required to prevent excess motion of the workpiece, and more locating components may be used as needed. Depending on the application, 4 common head shapes provide options to a fixture designer when selecting locating pins. The most basic type of locating pin head shape is the flat nose, and as such is used for the most basic type of locating, unidirectional external surface locating. This is effective at limiting movement using straight edges on the pin's side or on the top as a way to position a surface to a specific height. These may also provide lateral guidance when sliding a part onto a fixture, and can be used in conjunction with a datum edge to ensure correct positioning. The main disadvantage of this locating pin head type is its lack of versatility. Drop-down concentric locating is not recommended, as the sharp corners and tight tolerances can damage the workpiece in some cases. In order to prevent binding when locating, select a pin with a tapered or bullet nose. This can be used when locating radially, as the chances for binding is increased significantly when attempting to use 2 round pins. While tapered and bullet nose pins help prevent binding, changing to a spherical locating pin head can prevent or minimize the possibility of damage to the part when locating by drop-down method. Finally, locating pins with a diamond head shape allow for additional clearance on one side compared to a round pin. This is useful in eliminating or minimizing tolerance stacking, especially when combined with a round pin for radial or concentric locating applications. A key component in industrial automation, locating pins are a great tool when designing a jig or fixture. Whether locating on an edge with a flat nose pin, avoiding tolerance stacking by using a diamond pin, reducing binding with a bullet nose head, or preventing workpiece damage with a spherical tip, each head shape and pin type serves its purpose. Tune in to the next episode for more on locating pin mounting types.
And the third video, what we must to see, we must to look.
In this episode of Engineer to Engineer, we'll take a look at mounting methods with different shank types. If you're new to the series, check out the previous episodes to learn more about locating pin head types and the basics to work holding concepts. Before diving into mounting methods, it's important to grasp fit tolerances when working with locating pins. There are three basic types of tolerance fits: interference, transition, and clearance. Interference, as the name suggests, creates an extremely tight fit by using a slightly oversized shank within a slightly undersized hole. On the opposite end of the spectrum, a clearance fit allows a small amount of space between a slightly undersized shank and an oversized hole. The final tolerance type, transition, provides a near exact match between the shank and hole with slightly overlapping tolerance ranges. The most popular mounting method for most locating pins is the press fit, and utilizes interference to create a constricting fit by forcing the pin's shank into its respective mounting hole. While this provides a secure mount for the pin, it can be extremely difficult to assemble and disassemble, and is not recommended for short-term jigs and fixtures. If you're looking for cost-effective long-term solutions and have the appropriate assembly press, a press-fit shank may make the most sense. When a less permanent option, or one that's easier to assemble, is needed, a threaded or tapped shank may provide you with an optimal locating system. Tapped shanks utilize a slip fit, but require access to the opposite side of the base to fix the pin in place. Threaded shanks use a shoulder to locate the pin and fasten down tight with a nut. Keep in mind that due to a lower tolerance on the thread, the typical locating method is to use the shoulder of the pin and not the thread. The final type of mounting method uses a side-mounted set screw, and the locating pin will typically have either a flat to restrict rotational motion and fix it in place, or a notch. A notched shank will restrict both rotational motion as well as forcing the pin further down into the base, making it more secure in its placement. Now armed with the basic mounting methods and tolerance fits, you can make a decision of whether to use an interference press fit, a clearance or slip fit with the threaded or tapped shank, or a set screw and flat or notched shank for the locating pins in your jig or fixture. Tune in to the next episode to learn more about locating pins.
So we return to our lecture, and item 3.2, principles of constancy and combination of bases. Principles of constancy and combination of bases. Now we must make a 5 minutes break. We start in 12:30. 5 minutes break. Item 3.2, principles of constancy and combination of bases. The choice of bases during processing is of paramount importance in the design of technological operations. The highest processing accuracy can be achieved when all operations are processed from one base from one installation. From one base, from one installation. In real conditions, it is not possible to develop such technological processes. Since in most cases, the workpiece is processed on several machines. To avoid the accumulation of errors when reinstalling the workpiece, it is necessary to carry out processing on different machines from the same base. That is to observe the principle of base constancy. So when we use the principle, and why we use the principle of base constancy? To avoid the accumulation of errors. When reinstalling the workpiece, it is necessary to carry out processing on different machines from the same base. That is the first principle of base constancy. If, according to the technological conditions of processing, it is impossible to maintain the principle of constancy of the base, then the most accurately machined surface is taken as a new base. But you must do it only if, according to the technological condition of processing, it is impossible to maintain the principle of constancy of the base. Then the most accurately machined surface is taken as a new base. To improve accuracy, it is necessary to observe the principle of combination of bases. Second principle is the principle of combining bases. The principle of combining bases. Is that it is necessary to choose the same surface or their combination as bases for different purposes. It is expedient that the technological base should be measurable in the same time, at the same time. If the above requirements are not observed, there is a basing error. If the above requirements are not observed, there is a basing error. And when we have a basing error, that is not good for the processing of the part. So in the slide, you can see the check questions in our lecture. You can ask me the question if you have the question about the basis, about the type of basis and about of principle of constancy and principle of combination of bases. Have your questions? In the chat is nothing. You haven't the questions.